talk about the properties of exponents. So for any non-zero number, if we raise that to the 0 power, it equals 1. Okay? Any number raised to the 0 power equals 1. So if I say 5,000 to the 0 power, that is equal to 1. Okay? 5 million to the 0 power, that is equal to 1. All right? Negative exponents for any integer n and any non-zero number a, if I take that non-zero number and I raise that to the negative n, then you're going to take the reciprocal of a to the n. So for instance, let's say that I had 1/2, and I raised that to the negative 2. In order to get rid of the negative exponent, I'm going to take that 1/2 and I'm going to flip it. So 2. And that raises to the positive 2. So all you got to do is flip your base. All right, so in their example, they had 4 to the negative 2. And so this would be 4 over 1. So it would be 1 over 4 to the positive 2. Okay? So we're going to evaluate each expression. So if I take 6.7 and I raise that to the 0 power, that equals 1. Because anything to the 0 power is 1, except for 0. Okay? All right, but on number 2, I noticed that I have a negative exponent. So I'm going to take this negative 2, which is over a 1, and I'm going to flip it. And this will be 1 over, and then I need to keep that negative in parentheses here. Negative 2 to the positive 4. And then I can go ahead and simplify that. Negative 2 to the positive 4 is 32. And remember, it's important that when you have a negative that you're raising to an even power, that you put that in parentheses. And you can also just plug that directly into your calculator. If you have 1 over negative 2 to the 4 power. Oops, I said 32, didn't I? And it's 16. Look at that. It's a good thing we checked ourselves. 16. I went 1 too many. All right. So now we're going to go through and simplify some expressions that have more things in them. So we're going to write our answers using only positive exponents. So we want to simplify everything, and in the end, we should only have positive exponents, all right, and no zeros. So first things first, look at your top and look at your bottom and simplify them separately. So I have a 4. I can't do anything with that, 4. But I know that x to the 0 power is 1. So I have 4 times 1. And what is 4 times 1? It's just 4, right? Okay? And then I also know that y to the negative 3rd power, that's the same thing as 1 over y to the negative 3rd power, right? If I want that to change, I would flip this, right? And do y to the positive 3rd power. That's how I get rid of this negative. So in other words, you can kind of think of it like this. You have 2 sides to a division bar, right? If you have a negative exponent in the top, all you have to do is move it to the bottom. So if I have a negative exponent in the bottom, all I have to do is move it to the top, and it changes to a positive. So I don't need this division bar because this y to the negative 3rd is actually going to move up top and become a positive. So think of it like that. Think of it as sides. If you have a negative exponent, you need to move it to the other side of the division bar and change it to a positive. So if I'm looking here, I have 3 to the negative 2nd. So is that going to stay on top, or is that going to move to the bottom? It moves to the bottom. And then it's going to get multiplied by this y to the 0. But what is y to the 0? Anything to the 0 power is 1. So 3 times 1 would just be 3. And then what happens to my x to the negative 5th? Is that going to stay on top, or will it move to the bottom? It moves to the bottom and becomes a positive exponent. And then it's not that we don't have anything up here. It's just now it's all 1 over all of that. And don't forget your 2 right here. And we can go ahead and simplify that. 3 to the second power is 9x to the 5th. And for some people, it's easier for them to kind of separate things. So you've got 3 to the negative 2 and put that over 1. And then to do your x and say, okay, I've got x to the negative 5th over 1. And then I've got y to the 0 on the bottom with a 1 on top. And then you can say, okay, well, that's 1. If I multiply by 1, that goes away, right? This one flips. So the 1's on top and the 3 squared is on bottom. This one flips. The 1 is on top and the x to the 5th is on bottom. So if you like to separate it out, then you can do that. I think it's easier just to move it. Just don't forget that if you've taken everything from the top and flipped it, then there's a 1 on the top. All right, so I already know that 2 to the 0 is just 1. Okay, if I multiply by 1, that doesn't do anything. So the x to the second, is that going to move to the bottom? No, it's going to stay on the top. But the y to the negative second will move to the top. And I like to put things in alphabetical order, so that's going to go behind the y. And now I have all positive exponents, so I'm done. So we have a few more properties to talk about. We have the product of powers property. That just says if I've got like a to the second and I multiply that times a to the third, then I'm going to keep that base that's the same, and you're going to add these exponents together. So 3 plus 2 gives you 5. All right, same thing goes when you're dividing. So if I had a to the third, and I divided that by a to the, well, that looks like a D, a to the second, instead of adding my exponents, I will subtract. So I would do a, and you always do the top one minus the bottom one. So 3 minus 2, which is just 1. I wouldn't put anything there, right? And then you have a third property, which is a power to a power. So if I have one base and I raise that to a power, let's say 3, and then I take that and raise it to another power, like 2. See how I have a power raised to another power? I would multiply those, and that would be a to the 6th. So if you have two things being multiplied that have the same base, you add their exponents. If you have two things being divided that have the same base, you subtract top minus bottom. All right? And then if you have a power that's raised to another power, then you multiply those. All right, so we're going to simplify, make sure that we write all of our answers using only positive exponents. So if you look at this, I have a base of 3 and a base of 3, and I'm multiplying. So I will keep the base of 3, and I will add the 2 and the 6. And so for the sake of taking notes, we're actually going to write that out. That way if you look back, you know what you did. So this is 3 to the 8th, which you could get a number for that, but we're just practicing writing these. So we'll leave it as 3 to the 8th. All right, then if I look at number 7, I'm dividing, and I have a base of -4 and a base of -4, so I keep the -4, but I'm going to subtract, and you have to do top minus bottom, so 2 minus 7, so that would be -4 to the -5th, but we don't want to leave our answer like this because we only want positive exponents. So this is over 1, right? So I'm just going to flip it and then change the exponent to a positive 5. All right, so if I look at number 8, I have the same base. It's a y, right? So I'll do y, and then I'm going to do the top minus the bottom. So 6 minus 7, which is going to give me a -1. But I'm going to have to take care of that negative by flipping this. So I put it over 1. So it's 1 over y to the first. But do I need to write the first power here? No. So I'm just done there. So something else I just want to show you, because we've had 2 of these that came up to be negative. You can also think of it like this. You have 6 y's available on the top, correct? And 7 on the bottom. So think of it like this. Y to the 6 means y times y times y times y times y times y, right? 6 y's in a row being multiplied, yes? And then on the bottom you have 3, 4, 5, 6, 7. So you can cancel 1 y, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, right? So y divided by y, divided by, those are all 1, right? So 1 over, and then what do you have left on the bottom? Which is what this is, right? So you can think of it like this. If you have 6 on top and 7 on bottom, you can take 6 away from both of them. So you have 1 over 7, or 1 over y, right? Same thing over here. You have 2 on top and 7 on bottom, right? So you could take 2 away from both, right? That leaves you with 1 on top and 5 on the bottom. Does everybody follow me here? All right. Now I have 1 base, right? See, I don't have another base of 6. But this power is being raised to this power. So I keep that base, and I multiply negative 2 times the negative 1, which gives me a positive 2. I have my positive exponent, so I am done. Now I could go ahead and say 6 squared is 36 and finish that out, but we're just practicing our properties. All right. So now we have the power of a product property. This is like, let's say that I had 3a and I raised that to the 3rd power. Since I'm multiplying these 2 things in here, I can take and kind of like distribute to the exponent. You can't do that if you have a plus or a minus sign, but if you're multiplying or dividing, you can. So this would be the same as 3 to the 3rd times a to the 3rd. So if you see 2 things, and they don't have the same base, right? But they do have the same exponent, you could work this backwards as well and go, okay, well, these both have a 3, so I can put them together and raise them to the 3rd. So it works backwards and forwards, right? All of these do. So same thing, if I had like 9 over 2 raised to the 4th power. That's the same thing as 9 to the 4th power divided by 2 to the 4th power. Or if I see 2 things that have the same exponent, right, I can put them together and raise them to the 4th power. So if you look at number 10, it says write your answer using only positive exponents. I have 2 things I'm multiplying here, and I'm raising them to the 2nd power. So I have a negative 1.5 raised to the 2nd power. And then that's the same thing as taking the y to the 2nd power as well. I'm multiplying those. So if I take negative 1.5 and square it, let's go ahead and do that just for kicks and giggles. So make sure you have parentheses around it. Negative 1.5. Square that. You get 2.25 y to the 2nd. All right. Now, see, I have 2 things I'm dividing, and both of them are being raised to the 3rd power. So I'm going to take the top and raise that to the 3rd power. I'm also going to take the bottom and raise that to the 3rd power. And then I'm going to go ahead and simplify that just because I want to. So a to the 3rd. And then on the bottom, negative 10 to the 3rd. That's an easy one to do without putting it in, but just showing you. You get negative 1,000. Now, I don't like for you to write negatives in the denominator, so instead just put it out on the side. All right, now, if you notice on top here, do you see I have two things in the top and one thing in the bottom? So I have three things total to raise to the fourth power. I have 3 to the fourth. I have to take the d and raise that to the fourth. And then on bottom, I have to take the 2 and raise that to the fourth. So I have 3 to the fourth. That's 81. And I also have 2 to the fourth, right? Which I believe we did a while ago. So 81 and then the 16. So 81 d to the fourth over 16. And always make sure that you can't reduce the 8 like the numbers, 81 and 16. If you're unsure, you can always just grab a fraction and do 81 over 16 and see how it does not reduce at all, so you know that you're finished with that one. Now, I'm taking all of this to the negative fifth power, but I want to take care of that negative exponent before I do any kind of distributing to that. So when you have a fraction and you're raising it to the negative fifth power, all you have to do is flip it, and that raises it to the positive fifth power. And also, if you think about this, you know, I told you if you have a negative on the top, right, and then you have a negative power on the bottom, this one would move to the top, correct? This one would move to the bottom, and then you have that, right? But it's just easier to do it from here. Now I'll do 3 to the fifth power. On the bottom, make sure you take each one. So 2 to the fifth power and x to the fifth power. And then let's go ahead and simplify that. So we have 3 to the fifth, and we have 2 to the fifth. So 3 to the fifth is 243, and 2 to the fifth is 32. So 243, and then on bottom, 32, x to the fifth. And then make sure your 243 and your 32 don't reduce. So 243 over 32. No reducing. So I'm done with that.